measurements come with errors or uncertainty. Now, errors, or you always hear scientific errors, always is when it's discussed, it does not mean a mistake, unless, of course, it's a medical error, but that's again a different context. When we say an error, we mean this very important word, that is uncertainty. So uncertainty is ubiquitous in science and, of course, everyday life. But when it comes to science, for example, if you have this measurement right here, you might have seen this notation, plus or minus. This indicates the uncertainty. So for example, if I have 2.26 plus minus 0.01, this simply means that your value is somewhere between 2.25 to 2.27. Why? If I take this 0.01, notice that this 6 at the end right here is the uncertain digit. So uncertainty is encountered all the time in science, but that doesn't mean that we are severely limited. As long as we work with our uncertainty, we should be fine. Now, measurements done through different instruments or tools, even people, when they read, let's say, the scale in the lab, they read it differently. Or if you have someone, a family member at home, and you're making measurements, let's say to renovate the house, remodel, you might read, for example, the width of the room versus the length differently from the other person. So let's look at another example. If we have an orange here and we have 4 scales, and these scales are different in this sense. Let's say in the first scale, it only goes to 1 decimal place. When you go and you weigh this, you get 0.5 kilograms or half a kilograms. Now, the second scale, let's say it goes to 2 decimal place. So this is the first decimal place. And the second one goes to a second or 2 decimal places. So you get 0.47 kilograms. If you go now to a third scale, it goes to 3 decimal places, and you get 0.466 kilograms. And let's say finally, you want to just double check. You go to a 4th scale and you get 0.4658 kilograms. So if you did not tell somebody that this is the same orange, that person will probably think that these are all different values. But this is the same exact orange. So what happened here? Why do we have 4 different values? You might have guessed it. The scales actually round. So for example, this one was limited by the first, it only has 1 decimal place. So what it did, it actually rounded this value right here, the 7 that comes after the 4. If you remember rounding rules, is that anything 5 and above, you round up. So it actually rounded this 4 to a 5. Now, if you notice now, this 7 is also, let me erase this right here quickly though, 4. 7 is no longer a 7 here. Now it was actually a 6 that's followed by a 6. So again, the 7 also was the result of rounding the 6 in the second decimal place because a 6 followed. And now even this 6 is not even a 6, it's a 5, but it was rounded because an 8 followed it. So notice here that the most important thing you want to know out of this is that the last digit the last digit, is your uncertain digit. Now you are sure that you have a 5. You're not sure here that you have a 5. You're not sure you have a 7. You're not sure you have a 6. You're not sure you have an 8. It could possibly that this could have been a 6 followed by a 1 or a 3, but not in this case. So again, you need to remember that the last digit is the uncertain digit.